All right, high-speed intercontinental rail travel, pretty cool. Okay, so from that application, let's move to something a little bit more intimate. One of the biggest changes we've seen in human-computer interfacing over the last few years is the dramatic improvements in voice recognition technology that allows us to talk to our devices. So, to talk to us about how they're innovating in this area, please welcome to the stage Rob, Dan, and Chris from Cirrus Logic. Sounds like you got some fans in the audience. All right, now Rob, I'm sure everybody in the audience interfaces with Cirrus Logic technologies every day. Maybe some of them like right at the second. So tell us a little bit about Cirrus.
Well, for those of you who don't know Cirrus Logic, we're the leading developer of audio chips in the world today. We do audio, from smart homes to smartphones. We do great voice and audio solutions that touch the end consumer. We're very excited about 3 new trends in the market. The first is the use of voice as the command interface for the mobile phone. The second is the removal of the analog headset jack, which has afforded Cirrus Logic the opportunity to develop digital headset technology. And the third is the replacement of the mechanical home button with haptic devices that reside behind the screen. Behind me, you'll see a list of some of our customers. They're very demanding, and they represent some of the largest OEM developers in the world today. They require us to develop new products with new features on a yearly basis. Now, on that yearly basis, as we develop these projects, we have to come up with new test methodologies to make sure that we meet their demands.
Yeah, and I know, Dan, as Rob's talking about, as companies race to innovate like this, it's test departments, particularly validation groups, that get really stressed. Now, you figured out a way to solve this problem. Talk to us about it.
Sure. At Cirrus, we focus on best-in-class execution. We want to go from new silicon to data our customer can use as fast as possible. But like anybody focusing on execution, we often struggle with having engineers siloed or sharing best practices amongst our teams. We often even had multiple test executives that we would have on similar products that we needed customization and support, and that put a huge strain on our resources. So, to help with our standardization effort, we brought in Chris Cilino as our LabVIEW framework architect, and he partnered with our validation engineers and Soliton, an NI Alliance partner, and they gathered requirements and designed a solution for validation going forward.
Okay, Chris, so you're the guy brought in to solve the problems for Dan. Walk us through how you approached the problem and then the system that you built.
Sure thing. So when I started at Cirrus Logic, we decided to first take a step back and analyze the variability in our IP. Then we put together a whole series of hardware abstraction layers and an application that's designed to interact or interface with those hardware abstraction layers. One of the major challenges that we faced was in creating a user interface that would remain consistent and feel intuitive to our validation engineers, even as our IP was rapidly changing all around us. The Cirrus Logic Interactive Validation Environment, or CLIVE for short, is our main validation application written in LabVIEW and meets this challenge. So we're really excited to share with you all what we've come up with. So let's just take a brief tour through CLIVE. In CLIVE, those hardware abstraction layers of validation resources, such as motherboards and daughter cards, DACs and EEPROMs and FPGAs, and those all-important DUTs are displayed in a tree structure on the left-hand side of the screen. It's this tree structure that makes CLIVE intuitive to our validation engineers because that tree structure mimics the physical hardware sitting in front of the validation engineer. So in this case, our simulated project consists of a motherboard and a daughter card. And as I go about selecting on the different elements inside of this tree, CLIVE is going to show me the unique settings and options for each element, which is really awesome. And CLIVE lets me perform the critical low-level operations on my DUTs by double-clicking on the value of a field or register and changing it to whatever I want. So we're really excited about this. It's solving a lot of problems for us at Cirrus Logic. But remember, CLIVE has to be able to flex to any project's hardware configuration while still presenting that consistent user interface to our validation engineers. In this case, we had our simulated project which has just one motherboard and one daughter card. But you could easily envision a scenario where you have multiple parallel motherboards, each with their own daughter card hierarchies, each with their own sets of validation resources. The key element in CLIVE's UI that makes it intuitive and consistent for our validation engineers is this tree structure, because it can always adapt to whatever physical hardware is sitting right in front of them. So we're pretty confident that CLIVE is going to be able to meet the future needs of the validation department at Cirrus Logic.
Yeah, it's great. So you created a powerful and extensible user interface that remains familiar to the validation engineers, even when the device under test changes. It also allows them access to those important registers they need to do their work. Now, Dan also mentioned multiple test suites, and I know you would address that problem also.
Oh, yeah. So one of my mantras is to buy everything that you can and build only what you must. You see, we learned through experience that trying to design and develop, build and deploy, document and maintain a test executive was just way too expensive in terms of time and resources that we didn't have to spare. Thankfully, Test Stand has proven to be more than capable of interacting with CLIVE in an automated fashion to execute our test plans. You see, I chose to employ an architecture where we share those validation resources by reference between CLIVE and Test Stand, thus establishing a seamless communication between the two. So let's take a look at this architecture in action as we observe CLIVE and Test Stand working together. Here, CLIVE is showing us one of the fields of our DUT whose value is currently set to 0, and that's the default value. Well, I'd like to change that programmatically. So in this Test Stand sequence, I'm going to interact with my DUT by reference. And when my Test Stand step executes, you can see that CLIVE is automatically notified of the change in the state of my DUT. Therefore, CLIVE not only acts as our register utility, but can actually monitor the state of the entire system as Test Stand executes our automated testing plans and validation.
Automation and utility. That is the heart of CLIVE. So where do we go from here? We have a growing global organization, and we need to scale into that. So we need to have a vision of control across all of our labs with software deployment and development going on consecutively. And that's really a utility I don't want to have to design.
Well, Dan, you're probably in luck. I think you probably suspected this. We've got an announcement coming later in this keynote that should solve that problem for you. Now, gentlemen, before you leave, I do want to congratulate you. Cirrus Logic has been recognized as a LabVIEW Center of Excellence, so congratulations.
Thank you.
Please give them a round of applause. And thank you. Have a great rest of NIWeek.